Hi, this very short presentation is really meant to show you the difference between immunization following the infection of COVID-19 and vaccination. So please note that in spite of having a postgraduate degree in immunology and microbiology, I am not an expert in this field. My role as an educator is to try to explain things as simply as possible so that the majority of people can look at the information and make advised decision and just use the data to choose what they need to do. So this is obviously highly schematized. It is not meant to be an exact replica of what's going on in our bodies in response to a virus or a vaccine. So SARS-CoV-2 is a virus responsible for COVID-19, right? And it is made up, like many viruses, of three main components: proteins, lipids, and RNA, so genetic material. So here's just a very simplified depiction of how these components work together just to illustrate what the virus can or could look like, just looking at those components. Got it? Now, this is a more precise depiction of what the virus really looks like. Just note one thing: the many proteins that are present on its surface. There's more than one. So there are, in fact, 29 different proteins on SARS-CoV-2. Remember this, though. It's only the one that's called protein S for the spike of the virus that really makes a difference, that really counts in our response, our immune response to the virus. So our immune system makes antibodies against proteins. So for the sake of this illustration or this demonstration, we're going to show you only, like you see here, 5 proteins. Just imagine that there's only 5 proteins on SARS-CoV-2, one of which, obviously, is protein S for the spike. Again, that's where the immune system needs to go to protect us. Now, we produce antibodies in response to proteins. Because there are 5 here on the illustration that we decided to use, there's going to be 5 different antibodies produced because there are 5 different proteins on the virus. But remember, only anti-S is really important for us in terms of protection. So once we have produced those antibodies, they're now present in our system. They're waiting to identify the intruder, okay? And so once a virus enters the body, the antibodies are going to help the system identify that virus and neutralize it. So what we showed you before is a response to one virus. So one virus, 5 proteins, 5 antibodies were produced. Now imagine this. We're putting in 5 new viruses in your system after the first present. So you have your immune system working, right? You have antibodies, and there's 5 of them, and they're going to go and try to identify those intruders. So here's what's happening potentially next. So when those 5 viruses are in our system, those 5 antibodies will go and try to identify them, attach to them, and signal them to the immune system. So that's basically what could be happening, right? Now remember, only anti-S will generate a neutralization of the virus by the immune system. So it is fair to say that getting COVID-19 will generate some level of protection against the virus for future infections. It is. So if we do produce anti-S antibodies by being exposed to COVID-19 or SARS-CoV-2, why are we suggesting that vaccination ahead of time in anticipation of potentially being infected may be a better choice? So before we go to that explanation, let's always remember that when we get COVID-19, when we're exposed to SARS-CoV-2, the virus, we produce antibodies to a number of different proteins, not only to protein S. So if I only count on my immunity based on the fact that I had COVID-19, I need to take into account that I'm going to have a variety of antibodies that will potentially attack SARS-CoV-2, but they're not all effective. In fact, this is one thing that could happen. So let's say anti-E is already attached to the virus. Anti-S, the effective antibody, comes along, cannot attach because it's blocked, and it goes away. Another possible situation having a number of antibodies that are inactive to eliminate or to control the virus is the following. So I've got a virus like this, it is in your system, and the immune system sends anti-M, which, as you know, does not work in neutralizing the virus. What happens is that it goes away and the virus can continue to multiply. Anti-E comes along because it also is part of the immune system and it still doesn't work. Therefore, there's a continuation of virus proliferation. Now, because there's different antibodies that are potentially competing with each other, what may happen is that we're not eliminating a sufficient number of viruses, and therefore we're going to have still an infection, a multiplication of the virus in our body. Now the vaccine. The vaccines that are available to us only contain the information for protein S. Therefore, we only produce anti-S antibodies. So when I'm vaccinated, as opposed to waiting to get SARS-CoV-2 and building an immunity to it, so when I'm vaccinated, the army that I've produced is highly specialized. It's only anti-S antibodies. Therefore, all the soldiers that I have know exactly what to do. They aim and they take care of the virus. So once again, this is highly simplified. Just want to illustrate a difference between getting COVID-19, so we get immunity from it, right? We do get anti-S antibodies, but we also get other antibodies that are not effective to protect us, to neutralize the virus. The difference with vaccination is this. Vaccination gives us only anti-S antibodies. Therefore, we seem to have a more, as I said earlier, a more targeted, a more specialized defense against the virus. And this is why authorities and scientists and the data shows that vaccination seems to be more effective at protecting us against COVID-19 than having a prior infection and the immunity that goes with it. And then we need to think about the variants. Again, what's important is that if those variants still have the S protein, the spike protein, and we have anti-S, we should normally be protected against it. So the objective is very simple here. Help anyone make sound decisions. And any sound decision depends on three main factors. The first one is to be clear on the objective. What do you aim to do once you've made that decision? Then accumulate enough data to be able to verify, what are the potential assumptions. And finally, the third one is maybe the most important, is evaluating, weighing that information in a fair and balanced manner so that you can make the most advised and potentially better decision for yourself. Thank you for watching. Again, the aim of this demonstration was simply to provide a perspective, an illustration of what happens, and the difference between getting COVID-19 and getting vaccinated in terms of how we are protected against the virus. Take care.